Hi everyone, welcome to the WEBRTC working group meeting of the W3C. This is May 19th, 2026. Next page. This working group abides by the W3C patent policy. Only people and companies listed below are allowed to make substantive contributions. Next slide. This is the May meeting. We have a couple of future meetings coming up on June 16th, July 14th. No meeting in August, and we meet again in September on the 15th. Next slide. This is the meeting info. And we need a scribe.
I can do it, but only for 1 hour and a half.
Okay, that's perfect. Thank you. Thank you, Dom. The meetings operate under the W3C Code of Ethics and Professional Conduct. We're all passionate, but let's keep it cordial and professional. Next slide. These are the meeting controls. We'll use raise hand in Google Meet to get on the speaker queue. Next slide. This is some details about our document status. I think we're familiar with this one. Next slide. And these are the issues for today. The first topic, so we'll try to give a warning 2 minutes before the next time slot. And we can start with picture-in-picture window excluded while get display media. Tove?
Yes, hello. Yeah, next slide. Yes, so we've seen some interest recently in being able to exclude the picture-in-picture window from screen captures. So this is a window that is opened by the application itself. And I have some use cases here. So if you go to the next slide. So for instance, in a meeting like this one, you might want to present your whole screen, but you still want to kind of see the meeting controls, and if you have other people, you want to be able to see their faces to kind of get the reactions and so on. But of course, you don't want to share this window with the audience, so you would rather have the view on the right here with just the presentation itself. And if you go to the next slide. Another case is if you have like a recording application, you might want to record lectures or presentations or whatever, and in that case you also might have different controls that you want to have accessible so that you can work with your application, but of course you don't want those recorded. Next slide. So this is a small idea of how this could. This API could be that we have into the Get Media call. We add a new option to exclude or include the PIP window, and this would act as a hint to the user agent to exclude the PIP window opened by the same application. It will not affect other applications, but only if the application itself has opened the PIP window. And
can I ask a question?
Yes, absolutely.
Application meaning user agent or website?
Oh, application. I mean a web application in this case. I should have made that more clear.
Thanks.
And that was my short introduction to this. And I don't know if you go to the next slide for the discussion slide, or if we should stay maybe on the last one. I don't know what's best, but I'm open to other comments here. Yeah, Jan-Ivar?
Yes, so a question about the definition of the PIP window. You said the web page, it's only the PIP window that the web page itself opens.
Yes.
And I guess this could be video PIP, document PIP, doesn't matter.
Yeah.
And the other question I have, is this only for full screen sharing where this is an issue? Or because the obvious solution to me seems to, just to push back, would be to say that you capture a window or you capture, then you would avoid this, right?
Yes, so absolutely. The better way to do this usually is to use tab capture or window capture when possible. So the reason that we would like something like this is in some cases you actually do want to share your whole screen. For instance, if you do this kind of tutorial work where you want to kind of see how you do things on the computer, and you might open different applications and so on. And we all have also seen that despite our attempts to make people do tab sharing or window sharing. A large portion of users are still doing the full screen sharing. Maybe because they feel it more complicated to do it the other way, or perhaps they feel that that it's more convenient to just be able to like seamlessly move between different applications and so on. So it's for the use case of full screen sharing only. Yes. Yes, Tim.
Yeah, I'm slightly worried that it's not obvious to a user what windows will and will not be included in this. Like, knowing that this window is a pip window and it's from my application is not totally obvious. So maybe we need some clarity on that, or maybe I'm just not picking up on the obvious thing.
No, I guess that's a valid concern. I do think that this has become a quite common use pattern, that you have your main desktop and you have something floating on top of it, for instance, and the same on a phone, or for instance, where you if you have a YouTube video, you can have a pop-up window that kind of slides on top of it, and one would hope that users pick up that this like picture-in-picture window is kind of something different than from the normal Windows and desktop. But yeah, that might be a concern. Yes, Jan-Ivar?
Yeah, so I like that it's a hint. That means that, because otherwise my concern might be that the user might be a better judge of when it should be turned on and off. But given that it's a hint, I'm assuming you would allow a user agent to have the user override that decision if need be, right?
Yes, that would be possible.
Right. So yeah, I don't think I have a problem with this API. I guess I would just wish a more concrete definition of what counts as a pip window, since we could imagine this being questions around pop-ups and all kinds of stuff. But if it's a hint, maybe that's not. It would be good to get some web compat on it.
Yeah, I mean, I think the concept is, there is a standards around opening a pip window from a web page. Is that what you're searching for, or is it something else?
Well, so you're saying it's specifically those two APIs, the video pip and the document pip, and
yes,
not pop-ups and not any other dialogues.
Yes, I would say so, at least from my thinking right now.
Okay. Permission dialogues, all kinds of stuff. Yeah, everything else is in. Okay.
Yeah.
Sounds good to me. Ewan?
Yeah, quick question on, since it's a hint, we might not care too much about the default value, but I guess the default will be, in Chrome's implementation, the default would be to include the pip, and then websites would opt in to removing the pip. Is that correct, or?
Yes.
Okay, it's reasonable, I think.
All right, I'm not hearing any other comments or objections. So sounds like there's a general agreement. Tom?
So the next step is PR to screen share extensions or something else?
Sounds good to me.
Yep, sounds good.
Great, thank you. And next is capability elements. Thomas, is Thomas here?
Tom is here, but not sure if you muted. There you are.
Oh, I can hear you.
Just
Go ahead.
give me 1 minute, sorry.
Sure. For context, this is what used to be called Pepsi, and now it's called the capability elements.
Yes. Okay. Oh, wow. Thank you. Thanks, Universe. So I'm Thomas from Google Chrome Permissions, and I'm talking today about capabilities elements proposals. So I think this topic was discussed several times in the meeting. So I just try to give the brief context of what we are doing. So basically, the proposals is a shift in how we handle the permissions and media streams. We are evolving from the passive permission element model before, transitioning from the gatekeeper's permissions to provide kind of handle consent permissions, stream acquisitions, and provides the persistent trusted AI for management. So we move to a new capability elements, specific like several types of elements we have. It based on the use cases. We have user medias, we have microphone and cameras elements. That is for user media elements that is using for the site would like to have the stream with both cameras and microphones. And cameras and microphone elements are typically used to acquire one capabilities with a single track of audios or video. We also have draft specs and the details of definitions, repairs ongoing, and there will be a couple of issues we need to resolve before landing the first version of that. Yes. Next, please. Sorry. Yeah. So, so how it actually works? So let's give a brief how the IDLs and the sample code. In the top left is the web IDL definitions, and the central component is like user media element interface. I will skip the cameras and microphone element here, but the IDL is very similar. Essentially, the elements exposes properties like streams and errors, giving developers a clear synchronous access to the results of media requests and permission. It also provides the set constraints method, which is for the site used to specify what they need, like setting the video site or requesting the audio properties like echo cancellation. We propose several event listeners on cancel, on errors, and on streams. So that help us to shift from the complexity away from the promise into the event-driven models, and with the simplified error handlings and stream attachment. Yes. And after we get a stream, just simply attach to the video players or doing some like further for the site. There's kind of some simple code in the right, mostly how we doing kind setting the constraint in some simple way. Listen to the events is very familiar with the JavaScript. Okay, well, just feel free to interrupt me if you have any question. So next, yeah.
So one question I have, if you could clarify, I see that the constraints dictionary is slightly different from get user media, which means that there's no way to set video true or video false or audio false. So could you clarify a little bit about, is the assumption that user media element, you're always if you're using that element, you're effectively asking for both?
That is a good question. I think you can go to the next slide because it's one of the issues we want to resolve.
Okay.
Yeah. So here we are, here where we currently are in the spec graph, and there are some open issues we are actually trying to resolve with you and working groups. So you will see here the main issues we have. So one of them, that is like how we there's ongoing discussion in the PR that whether that user media element should like strictly require constraints for both audio and videos, because like I think the journals just that we should either remove the set constraint API, or we should restrict the user media to have the combined constraint of video cameras. For example, if you set audio false or video false, that will be error. Yes, this is one
Right.
point. Yes.
Ewan?
Yeah. So the first question is, do we need to set constraints for the user media element? And then if we think there's a need, then we should probably indeed restrict it so that you cannot do audio false or something like that. And the question is it needed to set constraints? From what I heard, the main use case is like to have a prompt that you add initially, and then you get the permission and you can restart capturing with what you want. So in that case, maybe it's not really needed. But if websites on the other end are actually using it to have one prompt that combines camera and microphone and keep using it, then maybe it has some value. So as I understand it, the prompt implementation does not have it yet, this set constraint method. So I would be trying to wait to add it until we get some real energy from web developers, basically, and not be proactive there.
We actually added that the set constraint API. Yeah, and yes,
Oh, okay.
Yeah, and I think there's a case that like if the sites want to use the stream later, it's better that giving at least some way that developer can like specify the audios and videos properties from the constraints. Yeah.
So, yeah, so my feedback here would be that I think long term, at least, we want to,
Yes.
since we have three elements, user media, camera, and microphone, it makes sense to me that if you only want camera, you use the camera element. If you only want microphone, you use the microphone element. If you need both, then you use user media. So that's what I would like to see long term. I understand initial versions. If that's not acceptable, we have to find a way to a migration path away from providing false. And I guess one of them might just be to deprecate that use. And so if websites don't update, then they will find that their requests for maybe camera only would ask for camera microphone. Would that be acceptable?
We just implemented the user media, but not cameras and microphone for now. But we will provide the migration path doing that. At the beginning, that we have some of the idea that we use set constraints to indicators that the site will be using new user media elements. But there are some new idea coming that we will use some sort of origin child for that. So we will think about that and see.
And sorry, my follow-up question is also what happens if you don't specify set constraints? And my expectation would be that it would ask for both camera and microphone using default constraints.
Yes.
Great, thanks. So I should say I'm generally supportive of this API. So
yeah. That if the case that users, developers missing the set constraint, it will be default. But if they set like audio false and video false, it will be error.
Right. Well, I don't know. That's a WebIDL question, I guess. I don't know if true throws an error if it expects an object or not, or if it just gets coerced to an empty object. I forget. I'd have to look it up.
I would guess it's a type error, but maybe I'm wrong.
That could be.
I would hope.
If anyone knew it by heart, I'd be impressed.
Okay.
Okay, so I guess my only question is that is it still clear that I hope it's still clear that the permission here is tied to opening physical devices so that there will be a stream object always. or a track object if you use camera or microphone elements. That is still the case, right?
That there's yes, but is you mean that the case of auto start or something? It means
No, sorry, I just mean earlier versions of Pepsi had the ability to grant permission without actually opening the devices, and I want to make sure that that's not the case here.
no, not the case here. So if we click
Yeah.
on the elements, and the stream should start automatically if with the permission granted.
Mm.
I mean, we have idea that we might have disabled the stream in the privacy mode, but it's still under investigation now. I don't know if we can do that anymore. So let's give it.
Okay, so do you want to go through the different open issues here today, or looking for just to merge the PR? What's your next step, you think?
I would prefer that like we merge the PRs, and I mean we can resolve everything is make sure that the first version of PRs is going to be uncontroversial and we can land the future version of that with some like further functionalities. So I think
okay.
there are a couple of issues here maybe that's like very briefly talk about.
Right. You want?
Go.
Yeah, I don't disagree with merging the PR, but in that case, for any issue that we have related to something, then we could remove this thing from the PR and merge the PR. For instance, user media, if set constraints is not very clear yet, we can remove set constraints and add it later. Similarly, well, there might be other ways, other things like that as well. I don't recall. Yeah, for instance, it's not clear to me whether the user media element should react to camera stopping or microphone stopping and things like that, because it's difficult to handle. So I think I sent some comments saying, hey, do we really need to do the exact same state monitoring we are doing for camera and microphone element, where it makes a lot of sense, to the user media element. So if we're not sure, I would be tempted to remove that part as well and re-add it later when we are very clear about what we will be doing overall. So I'm fine with a smaller version of the to merge a smaller version of the PR. Where we are 100% sure that we have consensus.
That sounds good to me. I would like set constraints to be included though, because I think it's already defined to not accept false.
Yes.
So that seems clear to me. Thomas?
Yeah, I
You were
agree
saying?
with that. I mean, I
Okay.
agree with Jonas that we will like define any further issues later. Can you go to the next slide? And we have some kind of ideas that we already defined that is not clear for now, and we will leave later. We have at least 5 for now. Yeah. So, but
Yes.
agree with John that I think that set constraint is something we need. Yeah, in the download that we have some further, I mean, futures issue we need to figure out to make sure that we have further functionalities of elements. So please also taking a look at that and like giving more feedback for us. Sure.
On the previous slide, just quickly, if you can go back
Yes.
one, the secure context. I think the elements are not necessarily elements in general are not secure context, but get user media, which it's being called underneath, is. So I guess it should be obvious that the button would appear, but probably would not be functional, and might. I think we talked about maybe having a security error or something like that. Is that right?
Yes.
Okay.
Yeah, I had answered on the PR and had a different proposal that we actually make the element disappear. I disagree with that, or have you like there's no precedent for the immediate case, so I'm not sure if that's
right.
something you want.
Yeah, I don't have a strong opinion.
Okay.
Yeah, I think all the point here is uncontroversial. there's only question that how exactly we to specify.
Yeah, the specifying we can figure out, I think.
Thank you.
Well, what is the queue task to fire an event? What's the issue there?
So the issue is that you have the click event and you have the stream event, for instance, or the error event as well. And currently the error event is fired synchronously, and it's unclear what the order of the events is. So we should define it. And it's also tied to user activation consumption somehow as well. So we need to understand whether the click event handler is executed before or after the get user media call, for instance. So some tightening like this. I don't think it's very controversial, but still we need to do it.
Yes.
Yeah, that makes sense.
Yeah, thank you.
But that is something we can do either in the initial PR or follow-up issue, right?
Yep. I don't think that it's too controversial.
Great. Any other comments? Anyone seeing this for the first time having questions?
I guess the decision is to land at least a subset of the PR where we have consensus, and then treat all the open issues in separate PRs.
Sounds good to me.
Sorry, it's not entirely clear to me which part is expected to have consensus. Does it or does it not include set constraints?
I will need to look at it. So it's apparently implemented in Chrome, but I cannot see it on source.chromium.org, for instance. And if it's already implemented, then it's different than if it's not implemented. My position basically is since we want people to use camera and microphone elements, the less feature we have in user media element, the better the world is. But maybe not. So, well, we can discuss it on Thursday, I guess. Well, we have plenty of time now, but so we can continue the discussion, or we can leave it to Thursday.
Well, Thomas, correct me if I'm wrong, but my understanding of Chrome right now is that you have to set constraints, and that because that's how you find out whether the user is asking for camera or microphone or both.
Yeah, we are changing that. Yeah, we are changing that behavior.
Isn't it the type attribute that you plan to deprecate that is defining whether camera or microphone? So it's not related to set constraints, right?
Yes. Originally, we want to have to set constraint to some sort of migration indicators, but we will change that behaviors.
Sorry, can you clarify which behavior was the old behavior and which one's the new?
So we will change the set constraint and supporting the errors if audio false or video false, kind of that. And we will use the origin tries token to define if the site is want to use elements as the old behavior as a permission element. So that is the way to change. Yeah.
Okay. So to understand very clearly, so you're saying it's part of, so set constraints is part of the MVP since there are web developers that are asking for it. Is it correct?
Yes.
Okay. And so the plan is to introduce set constraints because it's not yet, it did not ship, right? It's not yet available to web developers. Or is it? Because as I said, I cannot see set constraints being exposed to HTML user media element IDL in source.chromium.org. So
I think it is. Maybe you can take a look at the web web platform test is more like exact about the IDL look like.
Maybe it's in page permission mixing. I don't know.
Because we have some maybe looking at the parser interface because we separated the interface
Ah,
at separate places.
Oh, okay.
So
So
maybe that's missing something, but maybe defined somewhere else.
okay. So let's look at yeah, I see unconstrained set. Oh, okay. Okay.
Yeah.
And okay, so it did ship and it has the behavior of allowing audio false, video false.
Yes, we have to change that.
Okay, I see. In that case, yeah, I guess it's fine to keep it in the PR. It's a bit sad, but that's life.
Tim?
Yeah, just to flag up my usual thing here to make sure that it doesn't get lost in the wash. Can we be confident that the side effect behavior on ICE candidates will properly be carried over from the permission pop-up? Because at the moment, the permission dialog has a side effect behavior on the way that ICE candidates behave, and we need to make sure that that does or doesn't change, or if it does, then we need to define what's going to happen in that respect. Otherwise, you'll end up with a different behavior if you're using this versus the older ways.
Yes, I think at least in the short term that is covered, because the element spec, the user media element effectively calls get user media at one point algorithmically. So I would expect that behavior to be the same.
I was asking for it to be documented that it is the same, or isn't the same. I want the documentation to reflect that rather than it just happening to be the way that it got implemented. If you see what I mean, I think there's a certainty we need.
We could add a note to explain that that's how. So it is guaranteed by normative algorithms, but it might not be the clearest. So I think it's a good idea to add a note to explain that. Would that work?
Yeah, I
Sounds
will
good
take
to me.
a check of that.
Good point. Thank you.
Can I just adding the note to the document?
Yes. Yeah.
Are we talking about this in media capture main? I don't recall whether we are doing it or whether it's ITF.
I think it's the ITF spec that says that.
So
Oh, I
Tim,
see.
maybe you also want it in media capture main then. I don't know.
That's a good point. ITF. Sorry. You have a good point that I think if this is in the ITF, they may just be talking about get user media, and it might not be obvious that it carries over. So it's perhaps worth filing an issue.
You mean in media capture main or in media capture extensions?
Well, you mentioned ITF, so I think that's where the IP mode is defined, and I think they just call get user media by name. So that means it's unclear.
I was thinking it was camera or microphone, but yeah, maybe I need to read it again. Yeah.
We should clarify that, I guess. I should note there's also on the horizon, we might expect to see local London's work in a WICG on local network permissions, which might also become a better place. I mean, it was always a bit of a hack to hang this kind of network behavior off of get user media capture. So hopefully someday we can stop doing that, perhaps. All right, anything else?
So just to make sure we are on alignment, so we merge the PR except for UN, you had pointed to one item.
I think set constraint is fine. So there is I put some comments on the PR. So I guess before merging it, we need to answer these, go through them maybe on Thursday, and maybe some of them will trigger some edits of the current PR. and then we will be good. Like for instance, the user media element, whether we need to do state monitoring like camera and microphone, it's unclear whether it's a good idea to me. And I think it's one of the comments I had on the PR.
Okay, so that will be settled at the editor's column here.
Yeah.
And on the IP mode thing, do we want to record anything specific?
Filing an issue would be good, yeah.
Yes, but who will file an issue where, I guess, is part of the question. Because I'm clear whether we were thinking of making it a media capture main discussion or just at IETF, and if IETF...
Well, I guess we could start filing an issue. Sorry, Harold.
I guess we could add notes in both because WebRTC specs are easy to fix, and maybe we could consider updating the IETF spec, but it might be a bit harder. Harold, what do you think?
So the problem with this particular hack is that it's actually rather badly defined. And I think we could do better by separating out the concepts. And I think that belongs in WebRTC land. I mean, the concept of having permission to do lookups on a network or to access IP addresses, which just happens to be activated by this hack mechanism and could be activated by some other mechanism that lots of people have asked for. I think defining what the permissions are and how they're triggered, that belongs in the WGC. And then there are some pointers to that kind of thing in IETF land, and they need to be updated. But WebRTC first.
So something like we reuse the modes definitions from the IP handling IETF spec that we use them in WebRTC PC spec, for instance. Something like that.
Something like it, but not quite.
Okay, so maybe filing an issue on WebRTC PC then would make more sense. Yeah.
Yep.
Tim, would you be able to file it?
Probably. I will have to find the right place to do that. It's been a long time.
Okay, I guess it would be WebRTC PC GitHub repo, WFC repo.
Yeah, that'd be great. Just FYI, so I agree basically with everything that was said here, that I've already filed one issue yesterday on WebRTC PC already, since MDNS, which also depends on the IP mode, conflicts with some of the OS permissions that are being added for local network. So, but I also agree with Harold that there's some compatibility differences here, specifically as I recall, in Chrome you have to have permission. You only need permission, not active capture, but you need both camera and microphone. In Firefox, you only need camera or microphone, but it has to be active capture. So a lot of paper cuts in that area. So thank you, Tim. Filing an issue would be good. Okay, I think we have 2 more minutes. We have our actions, so we can go ahead and try to merge the PR Thursday. Sounds good. Thank you.
Thank you.
Next is RTP transport update. Philip?
Yes, thank you. Right, Guido, you can go to the next slide and the next slide. Right, so I know we had a presentation about RTC transport way back, so I kind of expect that maybe no one remembers or maybe even understood what it was in the first time around. So I'm gonna do a presentation basically describing the API at a high level. I'm not going to go into much details right now, but I just want to present it in a way where I hope everyone gets a pretty good understanding about what it is. So this is an API, a low-level API for sending and receiving datagrams, and the basics gives you an encrypted transport, like that's non-negotiable. The user can't opt out of the encryption, and it also allows peer-to-peer communication. And the low-level part of it is the fact that this has datagrams. There's no formats or protocols enforced by the transport. So it's all up to the application to decide what they want to send and how to interpret it. It also means that you have more kind of direct access to the network, in the sense that when you send a packet in the browser, it's going to result in one packet on the wire. The application also decides when packets are sent, so they schedule and decide on when packets are sent, and the app also decides on kind of which network route. This is a general term we use to describe, like, which interfaces or which IP addresses or 5 tuples should use to send a particular packet. And the app also kind of manages which candidate pairs it tries to probe, it tries to connect via, and discover, and so on. So it can, So in that sense, it's quite low level, that you give the application a lot of power to both establish connections and how to manage those connections, and when to send packets and at what time, and so on. Next slide. So, and what we could do, or what this gives you in comparison to peer connection, because this effort is kind of this is kind of an attempt to create an alternative to peer connection. So what this would give you is custom packetization and payloads, your datagrams. You can do custom pacing and bandwidth estimation, because without the pacing you can't really do, you can do some form of bandwidth estimation, but here you can integrate the pacing and the bandwidth estimation in your own control loop. You can do custom RTX and FEC, and you can do custom network route management. Like, you can basically implement your own ICE agent, and packet forwarding, and more stuff. Next slide. So I was going to go over the API. It's a bit much to fit in one slide, so I'm going to do it in 3 parts. Next slide, please. So this, I can tell you up front that I'm kind of presenting the API in the opposite order that you would actually use it. But this is kind of the core of the API, because this is what it all comes down to. This is like how you send packets and how you receive packets. So there's one function that is kind of central, of course. That's the send packet function, and you can give it a bunch of packets to send, and you also just hand over which network route these packets should be sent over. And to receive packets, we have an event handler that will tell you that you have received a packet on pending packets received, and it will just give you it will fire a single event when you receive a packet, and then you could receive potentially multiple packets, but until you call get received packets, this event is not going to fire again. And the reason for doing this is to batch incoming, outgoing events, like metadata, or we also have this, for example, get packet sent info, that will return some meta information about how the packet was sent, at what timestamp, and so on. So this is all for performance reasons. So how you would use this is, for example, the RTC packet to send. Like, if you're gonna call send packets, you create your own RTP packet to send. It has an ID that you assign, data you generate, and you decide on the send time. And then when you get the RTC packet sent info back, you have the same ID. It's just your cookie, and we also tell you what size it ended up being on the wire, and the send time. Again, for performance reasons, we allow the browser, or agent, I think it's called, to kind of batch sending and stuff like that. It doesn't have to be the exact timestamp that the user provides, but it should be close. And then we also have the receive side of things, where you also get an event, and you can get those received packets with a function call, and then you get the data, the receive time, as close to the socket as possible, and the network route it was received via. So that's that's kind of how you would end up using it once everything else is established. Next slide, please. So this is the second major part of the API, I would say. So when we design this, we try to future-proof this as much as possible, in the sense that, we might want to support quick later. We might want to support other mechanisms for establishing connections. So we have come up with this kind of modular design where when you create an RTC transport, you in the constructor, you pass it an RTC transport config, and there you can, for example, specify which network route controller you want to use for this RTC transport. So right now, in the kind of initial version of the spec, we have something called ICE automatic and ICE manual. ICE automatic is kind of what you can imagine the ICE agent in interconnection is like right now. ICE manual would give you way more low-level control, where you can decide exactly on which candidate pairs to probe, which when you gather candidates and all that kind of stuff. So with that API, you could basically implement your own ICE agents. Right. And let's see. Right, we also have this set format. And again, with the initial version of the spec, we have something we call ICE DTLS/V0. And the idea is that, with time, for example, the /V0, for example, that indicates what the, actually, let me skip that for now, because I'm going to talk more about that later. But this basically says, like, okay, we're going to use ICE, we're going to use DTLS, and we have a version number as well, because we're going to invent some way of communicating or how we establish things with ICE and DTLS. But in the future, we might want to update it to work some other way. So with the version number, we have a way of updating it. But we also, as I said, we also want to support, potentially support other wire formats and other formats in the future. And again, right, this RTC network route controller. So if you remember in the previous slide, when you called send packets, you had to provide an RTC network route. And this RTC network route controller is basically what gives you RTC network routes. So yeah, that's when you establish a connection, then you're gonna have a blessed object that is an RTC network route that you can pass to this function. Yeah, next slide. All right, and then the third major aspect of this API is the circuit breaker. So since we give the user the ability to generate packets and decide when to send them, that could pretty obviously lead to bad things. So we're gonna have something in place to kind of prevent bad things happening. So the way this works is that we have a transport level header that is attached to every packet. And this is not part of the wire format. It's not something that we expose to the app. It's just something the RTC transports on either side can read and use. And it basically contains feedback information like transport wide congestion control, for example, like something like that. We haven't decided on the exact format yet. And then this circuit breaker can monitor the network, and it can basically stop you from sending anything if we consider the network to be overloaded, or if you're not behaving well. And the idea is that this circuit breaker should be lenient in the short term. Like, we don't want to interfere with any form of reasonably behaving congestion control algorithm that you might want to try to implement. Even if you try maybe some probing, you might send data in some bursts. In the short term, that should be okay. But if you continuously, or during some I don't know, we haven't decided exactly, but like a few seconds of maybe oversending, for example, that could lead to us tripping the circuit breaker and stopping it from sending. So that's what this is. And yeah, those are the kind of three major parts of the API, I think, or what this API provides. Next slide, please. Yeah, and this is kind of the full overview. So the things I didn't talk about is kind of encryption and error handling. It's just a bunch of details. I don't think it's there because it needs to be there, of course, and it's interesting to talk about these things. But I think for the sake of this presentation, it doesn't really add much in understanding what the API is and kind of how it's designed at high level. So I decided not to talk about it because it's just a bunch of details. Yeah, but anyone is of course anyone can look up the current state of the spec to see what's going on in detail. Next slide, please. Right. So what's the status? Yeah, so we have done a lot of progress on the specification. I left a link to the latest draft here. So we have decided the shape of the API, and we have started kind of translating our whole, all the design decisions and everything we made into an actual spec. Some sections are not yet fleshed out. Like all sections have some text. You should maybe be able to understand most of it, but there are some sections that still needs to be fleshed out. All sections need to be polished. Yeah. There's also exists a prototype that we implemented. This was a while ago. It's pretty out of sync with the spec, but if you want to just try to send and receive packets in the browser, you could try it. Like, yeah, that is pretty out of sync by now. And yeah, that's it. Yuan.
Yeah, since you were talking about prototype, I was wondering whether you, and since you were also talking about efficiency and having APIs designed specifically for efficiency, I was wondering whether with the prototype you try to implement the same streaming application with web transport and this RTP transport and see and compare in terms of performance where you were able to go, for instance.
Are you saying like did I try implementing some form of application to compare the performance?
Yeah, basically, yeah. Because you're saying, hey, we are doing this API because we know that for perf it would be better, and since you almost have a prototype, I was wondering whether you have a proof somehow.
So okay, the things we have tried or the things we have done is that in the prototype, for the sake of compatibility with peer connection, we actually support some like SRTP wire format, even though we don't maybe intend to support that in the final spec. But yeah, so we basically created a WASM version of peer connection and ran WASM in the browser to see that things worked reasonably well, and they did. If we have compared it to other transports, not really, but okay, I wasn't quite expecting this question because in my mind, this is just me talking about what I think is from my point of view, think is
it's fine to not have done it.
No. I'm just saying that in my mind, like the needs of, for example, peer connection is completely different. Like in terms of bandwidth estimation and congestion control and prioritizing packets and like maybe even canceling. Yeah, it's very different.
Yeah, I agree that this API is closer to web transport, and we talked in the past about web transport and this, whether they're somehow redundant, whether web transport could be extended.
Yeah, I think one thing that web, like,
yeah,
first of all, it's peer-to-peer. Web transport doesn't do that. The second thing is that you can't implement your own congestion control if you don't control the pacing or if you can't schedule when packets are sent. So you can't iterate, you can't try new bandwidth estimators, congestion controls, stuff like that, which is pretty major part of like in terms of development and for improving real-time media. So those things are, I would say, pretty.
Yes, I see. So what you're saying is that for implementing this bandwidth estimation, we need additional information about the timing that we don't have in web transport, for instance.
Yeah, it's not only about additional information, it's about controlling, for example, when packets are put on a wire. Like because bandwidth estimation and releasing packets on the wire can go hand in hand. You need like a tight loop to excite the network, see what happens if you try sending it in various ways. So if you can control that, the type of bandwidth estimators you could implement are very limited. And I'm not sure if they would work well for real time.
Well, there are others in the pipe, so I will stop there. But it seems to me that API wise, I'm still unclear there. So yeah, there's something to dig there. I should probably file an issue to precise what I'm asking.
Right. Yeah. That'd be good. Thank you. Jan Ivar.
Yeah, so I would support Johan's quest for more information here about performance. I mean, you mentioned Quick Web Transport already does datagrams, so it'd be good to compare to that. There's also data channels, which I think Tim will touch on. You could ask, what is the performance benefit here over just using data channels? The API, like I don't want to be a broken record. I've given the same feedback before. I think asking web developers to choose a totally bespoke API because they're doing peer-to-peer is short-sighted. I think we should do better trying to unify the web APIs here. That's a lot of criticism we've gotten in the past, so I think we should try to do that. I have some specific questions about datagrams in web transport. I should mention are part of Quick. They are congestion controlled and flow controlled. And so here, it doesn't sound like you have the browser doesn't have any way to, other than a circuit breaker, to basically say, it's giving a lot of control to the website. So for instance, if you open 2 web pages in different tabs using this API, how would they work? How would they interact? And you leak in information.
Sorry. I guess there are multiple questions there. I mean, okay, so coming back to the web transport and like performance-wise, as far as I know, web transport doesn't have a real-time congestion control algorithm built in. Like they use BBR, which is much better than maybe Cubic or whatever. And we have tried BBR, like we have done internal projects to try out BBR and how well it performs for real-time use cases, and it just doesn't perform well at all. So as far as I know, when you're actually bandwidth limited, BBR doesn't really perform well at all. So I'm a little bit. So why? Okay, I guess I could flip the question, like why would WebRTC or web transport work well for real-time use cases if it doesn't have a real-time congestion control? I mean, I don't mean to get into a discussion, but
there's yeah. The congestion controller is not specified, so it's up to each implementation to pick one. And I think there's an API service at least it's a tip of the hat toward asking for more low latency choice in congestion controller, but nobody's implemented that yet. I guess the question is, we can try to improve on that. We can try to make progress in web transport for lower congestion controller. Is that the only reason for this API?
No. Okay. So no. Right. So I think there are 2 things that this API that I'm proposing would enable. So one thing is that you can, like, if you were to implement a low latency congestion control in web transport, that would still be fairly fixed. Like rolling that out and trying it out, iterating on it could take a lot of time. With an API like this, it's basically whenever you refresh the homepage, you could try something else out. And the ability to iterate quickly, I think, can't be understated. Like that's a major factor in actually progressing. So I think that's one of the things this enables. The second thing it enables is that there's no low latency congestion control that you could build that works well for any application. Like that's the thing that let's say we Meet, for example. If you're doing one thing, we would want a different behavior compared to when you do another thing, because the latency requirements are slightly different. So depending on how we decide to send, how we decide to probe, how we decide to ramp up and stuff like that, depends. If it's fixed for various use cases, then it's already not performing that well. And this is where you get into like a very application specific behavior that you want to have for just your application. So even if you had a low latency mode in web transport, that would still not be optimized for your application. It would be some general low latency congestion controller. So I think that's another thing that this API would enable.
Yeah, so I'll let Tim go next. I just want to repeat the request for measurements performance measurements here would be very welcome, because I think otherwise I would question some of the design choices. Like my understanding is this is exposed on the main thread, and web transport in contrast is available in workers, but also has a sender queue for datagrams. So I'm surprised a little bit that here it sounds like there's not. And I understand that the networking is usually a separate process in most browser implementations. I'm wondering if you had thought about
that. Look at where this is exposed. That's something we have yet to discuss in detail. There are placeholders. So unfortunately, if you read it back in its current state, there's going to be, hey, what's going on here? And it's probably because we just haven't talked about it in detail well enough yet.
That's understandable. Yeah, but some measurements would be awesome. Thank you. Tim?
Yeah, so in lieu of actual hard measurements, I have actually done an experiment with this, with the Blink prototype, to see how it behaved as compared to the data channel. So the context I looked at it in was a LiDAR. So it's real-time data. You want low latency, and there are use cases where you'd like it to be peer-to-peer. You can't use RTP because there's no RTP format for it. So the only thing you could do is like stuff them into an SLIN packet, which is what some people do. But then you get into jitter buffer, and like there's a whole load of fun that you have to kind of get into. So you can't send those packets over RTP. Obviously, me being me, I did this with the data channel, but what you stumble over there is that data channel really doesn't do loss well. Like if you send much more than the network can cope with, the data channel, however much you apply all of the new RFCs, you still end up with something that is gated on a single TSN. So you get to the point where you have to have, if you drop a packet, then the sender has to say, and by the way, it's okay to not receive this one, which requires you to send another packet. So that it's fundamentally not, the data channel is fundamentally not happy with high loss. So I built this, a version of the LiDAR peer element to drive this, and it works nicely at 2.5 megabits a second. I get nice little graphs, and all of that works. Now that's not gigabits. It's not a huge performance test, but at least it works. And it does do the thing I want, and it also has the interesting attribute of being able to, I can apply my own congestion control, I can apply my own prioritization to what goes onto the wire. So that means that if I notice that like I'm losing bandwidth, I can maybe send every other packet and this kind of stuff. So I can have my own algorithm there, which I think is genuinely interesting. So I'm very supportive of this thing's existence, and I have played with it to some extent to prove it out. But no, we haven't done like gigabit point-to-point transfers to see whether it beats web transport for that. But for me, this is really interesting for things which you simply can't do because you want both peer-to-peer and your own congestion control. So anyway, I've played with it, and I'm kind of reasonably happy with the direction it's going in.
Right. So maybe I misunderstood the question about performance. Are you talking about like how well would web transport support like an RTC use case, or are you asking like how well, like how many megabits per second can I cram through an RTC transport if I tried, or what type of performance measurements are we interested in?
I think either would be good. Comparisons are always helpful, and I think it's more about there's a lot of bespoke API surface here to justify, and I think being able to justify that, it would help to have performance measurements that show. It's not obvious to me from the slides that this is beneficial.
So We have done some performance measurements on just raw performance, how many megabits, and with some patches internally to Chrome to update some buffer sizes and some other behavior internal in Chrome, we could send a gigabit through this API. And like the CPU usage being fairly reasonable, but I guess that's not the performance measurement you're interested in.
It's more to make it relevant to, numbers are hard to understand in a vacuum. So comparing it, for instance, to web transport or data channels, if you prefer, or both, would be helpful here, I think.
So I think there's one more thing in terms of motivating the whole API separate. Well, there are many things I think, but another thing is, for example, that this API would allow you to manage your own network routes. So would that be something that could be added to web transport, for example, or would you be able to implement your own ICE agent, basically able to probe, what active connections do you have available? How often would you probe their RTTs? How would you select between them? How would you fall back between them? Something that the API would also allow.
Yes. Yes. So to answer that, I would just say that those are good questions, and the benefit of web transport has is that it's built on top of Quick, so we're not making up the network layer just for our API. So Quick already has a lot of features that we could take advantage of, like multi-homing, or what's it called, where you can change, forgetting the word now, but you can change route dynamically if you move. It's walking into the parking lot, and stuff like that. And that's actually a bit of concerning that this API seems to be basically doing networking in the W3C, or part of it. So I guess I question if this is the right place to do that.
So in the thing you described where Quick supports roaming, because I guess that's the thing you're talking about, that you have a connection ID and you can basically receive packets from any 5 tuple as long as it gets to the server or the other end, who's sending the packet. That's not the same as kind of managing your routes, because you have to decide when you want to switch network route and how you would want to fall back, and how you prioritize between them. So even though that's supported both via ICE and Quick, but to actually manage your own network connections, it's not the same thing as supporting roaming. This is more kind of extensive and, as I said, more low level. Like you expose more to the user.
I think the interesting test one could do, although it would take a bit of setting up, and we probably want to wait until this API is a little bit more mature, would be to see what happens at saturation point with the data channel. So you're starting to lose a lot of data, and at what point does it collapse completely versus this API where I would expect that you'd be able to get closer to the actual capabilities of the network. So I think that would be an interesting experiment to do, but I don't think we're in any position to do it as yet.
We are at time, so if we can take a few minutes to wrap up there. So my understanding is that maybe Jonivar could file an issue, and I could also file an issue, or maybe comment on Jonivar issue, depending on who filed the issue first, to continue the discussion there.
That makes sense. Thank you.
Thank you.
And thank you so much for the presentation. There's a lot of good detail. I appreciate the detail.
Thank you.
Thank you. All right, next, is it Ewan S-Frame?
Yeah. Okay, so we're diving into details about S-Frame. So there are a bunch of issues, small issues, hopefully, that we need to discuss. So currently, when you're attaching an S-Frame native transform to a sender, you need to set a key to that transform, and it will do encryption for the whole media. And it works very well when the sender is just sending one stream. But the issue is what happens in case of simulcast. So now you have a sender, and if you have like 3 layers, then you have like 3 simulcast layers that are sent in parallel, different SRCs and so on. So one option is to reuse the same key for all 3 of them. And another approach is to use different keys for each stream. And it's really, I guess, up to the web application to decide what they want to do. So currently, my guess is that we are supporting the reuse of the same key, but not the use different keys. Yep, Harald?
Just checking, is the encryption defined in such a way that each of the streams will have different IVs?
I think so, yeah. Oh, interesting.
Because the reuse of keys across multiple streams without the same IV is a classical.
So it's another issue. Yeah, I guess. So we need to specify that somehow. So we could do nothing, then we use just one key and we encrypt them all as if they were like one stream, which doesn't make a lot of sense. But in any case, so yeah, you could file the issue or I could file it. It's up to you, Harald. Good point. So, but if we're getting back to that issue here, it's really questioning whether we should allow website to support different keys for the different simulcast streams. With script transform, you can do it, but currently with S-frame transform, it's not clear. So there are different ways of solving it with an optional read parameter so that you can set encryption key per read, for instance. There is also in the S-frame RTP draft a key derivation mechanism, which is you have a base key and you derive it based on the SSRC that is being used. So we could add an option to the S-frame standard transform to do that. And another option is to do B plus C. So I'm wondering what people think about whether we should try to tackle this issue or whether option A is good enough or not. So thoughts? Yep.
So if the IDF folks where there are more crypto folks on the ground than here have already put into the spec in the RTP draft that you do a key derivation on based on SSRC.
It's optional. Yeah.
Then that seems like an excellent option to follow. Don't invent something new. First rule of crypto.
Yeah. Okay. So you seem to be interested in C, I guess.
Yep.
Is there anybody else that has thoughts on that?
That sounds like a good option to me.
I'm not clear why you need to add an option for. So C has 2 bullet points, and the second one I'm not too clear about. I understand the first one mostly, but the second one I don't understand.
So maybe let's say you don't have simulcast. You have a sender and you have a key, and you might want to apply key derivation, but maybe you already know that it's the key material that you want to use, and you do not want to do key derivation based on the SSRC. So the option would be to say to sender transform, here is the key, and now you have a Boolean in addition that will tell you whether you use that key directly or whether you derive it based on the SSRC.
Okay, and there are situations where you would want to do each?
I'm guessing currently people, like the initial approach was to say you provide the key material and you don't do key derivation at all, because it's really a web application decision whether to do this or not. I know that some applications do that. They're doing always SSRC key derivations, but I'm pretty sure that some applications do not do that. And so
it's a compatibility issue.
Yeah.
Okay.
Harald, then Peter and Casper.
Options reduce interoperability. So if we only have one way to do it, that's usually better.
So you're saying enforcing SSRC key derivation?
I think that's that should be our default position, and we should have a strong argument for departing from that.
Okay. I'm interested in Casper thoughts then. Who is next there? What do you think?
I'm just concerned about the CFUs which are doing the SSRC rewriting, because you would need the same SSRC to decrypt, right?
Not necessarily. You can do your derivation on your own and then send the derived key on the end recipient as well. But you will need to know what is the SSRC before, so that can trigger a potential issue there. Hence why sometimes it's better to have an option.
Yeah.
Do you know what WebEx is doing there? If it's doing per SSRC key derivation or not?
No, we are not doing per key.
Okay, interesting.
SSRC.
Okay, thank you. Peter?
So, correct me if I'm wrong, the only reason you would want to use different keys is to avoid nonce or IV reuse. Is that right?
You have 3 different media streams. You can use 3 different senders and have different keys or not. My interpretation would be that maybe you want to have different control, whether it's small, medium, or high resolution layers, for instance.
What I'm asking is what is the motivation for having separate keys? Like with an RTP session, there's just one key. Well, RTP, RTC, whatever. But for RTP, there's just one key. But the SSRC is included in the IV. So here, why do we want separate keys instead of just including prefix in the IV?
Well, yeah. I know that some other applications are doing key derivations for different senders there. So
I just don't understand why you would want separate keys. That's all.
And so with key derivation, they're all derived from one key. So effectively, you would set one key, and then it's just an internal matter on the how do you do the encryption that is affected by the choice.
Right, but with SRTP, we don't do that. We don't derive a new key for every SSRC. We just include the SSRC in the IV when doing the encryption.
But it's end-to-end, while SRTP is hop by hop, right? So
yeah, I'm not saying we would use RTP here. I'm just saying SRTP. I'm saying you can use one key but have separate streams by just having a certain space in the IV, some bits that represent some stream ID.
Actually, the SRTP uses a different key for RTP and RTCP. It's just derived with a different bit in the key derivation algorithm.
Yes,
but, as I said, it's mostly internal.
But I'm trying to understand the motivation. That's all. Or are we just saying that the difference between putting the bits in the IV and deriving a key is immaterial, and we're really just trying to decide how to distinguish between one thing and another? Or and maybe another question is, what is the IV right now? Like with RTCP messages, it's just an incrementing number on every single RTCP packet. What is the S frame approach? Is it there's some frame number in there, right?
Yep, I'm trying to look at it now.
So that the reason I don't like C is because it's tying S frame to SSRCs, and SSRCs are an RTP thing, and it seems like S frame should be, well, I guess it's S frame RTP there, but like if you wanted to do S frame outside of RTP, then you would still, it seems like it would be nice to be able to do S frame with simulcast without using RTP. So having some
you mean
more,
without SSRC, you mean?
yeah. So having a more generic sense of stream ID.
Yeah, I think I will need to get back to some folks internally. But my approach was trying to mirror what is being done today with different senders on the same SRTP connection, but in case of simulcast.
But the way that's done is not through different keys. It's just, like I said, it's
it's different
part
keys.
of the IV.
It's different keys. At least some applications. I can try to check.
Oh, sorry. You mean in S frame, it's deriving separate keys for each stream when it's not simulcast. Oh, okay.
Yeah. And I don't know what I don't know what script transform web applications currently do with simulcast. Whether they are using the same key for all or whether they're doing something different. So I will need to check that as well. I guess that's another thing to check.
Yeah, script transform.
Okay, well,
doesn't,
if you're,
but applications built on script transform do.
Okay, so if you're saying that you're already deriving separate keys for each stream, I would say for each simulcast layer, just do the same. So I guess that's option B.
It could be option B or C. Really, yeah.
So I would support any option that doesn't add an option. But okay, I'm not.
I'm not sure it's feasible because I think some web applications will not want to do key derivation per SSRC, and some might. That's the issue there. Okay. Well, I think I have some more information at least, and I will continue digging into that. Maybe you can go to next slide and see whether we can make some progress. So S-frame and frame marking. So if you're using S-frame, probably there's an SFU in between. And if you're using S-frame, now the SFU is sort of blind. It cannot know very easily what the packet it's receiving is actually. Is it part of keyframe? Is it part of temporal spatial layer? So basically, the SFU being blind, it cannot like select some packets over some, like to drop some packets because it knows it's good to do that. So the typical way of helping SFUs when you're encrypting like this would be to use like RTP header extensions. There's frame marking, there's dependency descriptor. So I'm wondering whether in WebRTC encoding transform, there will be consensus on mentioning or using those technologies in implementations or in spec. I was also wondering whether enabling S-frame should also enable these header extensions if supported by default, or whether it's better to let web developers have full control and not have a default behavior. Thoughts? Yep, Pianivar?
Well, in WebRTC extensions, we do have the set negotiated headers API.
Yep.
So without having without picking a favorite, I would say we could have useful defaults and a customizing API at the same time. So
Yeah.
you could add this to the default, and that would be discoverable using the get negotiated. The get, I forget what it's called. Get extensions to negotiate.
So you mean it's added to the default for all transceivers, or it's added by default if you're using S-frame?
The second one, I think, but I'm not sure. Yeah.
Okay. Okay.
Yeah.
Just want to mention that API.
I'm kind of doubtful about making the packets more complex by default. It's cursed if you do and then if you don't. But I mean, adding a dependency descriptor to someone who is in a situation where they don't need them, it's a slight exposure of content of the content of the packet or of the stream that if we're doing S-frame for privacy, and people might want to not have that on by default.
You're right. At the cost of having like a less efficient transport or transmission. Yeah.
Well,
so minimization
transmission will be more
minimization of
efficient
exposure.
if you don't add those errors.
Okay. So mentioning support of those technologies sounds good to you, but enabling them by default, you don't think that's a good idea. Is that
That's my current thinking, yes.
okay? Yep, anyone?
Well, the caveat, my earlier comment is that not every browser implements the set negotiated header API yet. So it would create create more web surface for a web developer to remember to do all these things in order to get reasonable performance. So I also like the idea of web browsers having good defaults.
Depending
I'm
on
not
what
sure.
good. That's the question, really.
Yeah.
Is good the more privacy preserving or the more more efficiency preserving for the case of SFUs that look inside a package?
Good point. Well, I hesitate. I said it's argued for fewer options, but we can make that an option on the S-frame transform. Privacy versus performance. I don't know. Maybe not.
It's not supposed to be simple.
Casper, do you know whether Cisco is using frame marking with S-frame, basically?
No, currently not.
Okay. So you don't know, or you know that WebEx is not using it?
We are not, but we don't need it right now. But we are not using the S-frame, which is standardized right now. We have our own implementation for it, so we'll need to adjust our implementation to WebRTC 1.
So how is being done the packet selection then?
I don't know details, but I know we are doing it.
Okay. Thank you. So I guess I have like 2 or 3 minutes. So let's go to the next issue. So S-frame receiver transform. So let's say you're receiving packets and there is some errors. So for instance, the S-frame format is bad or there's a decryption failure. So it's good to let know your web application that it has some issues and maybe it should take action, like adding a new key from the ID. But at the same time, so the spec is saying that you need to fire events. But firing events for every packet or every frame might be a lot of events, especially if they're exactly the same. Like, hey, the key is unknown. Like the ID, I don't know it, so please provide me one. So I was wondering whether we could like allow SRAM receiver transform, not the stream version of it, to skip events if the errors are the same. And we could provide an algorithm for that. So that's option A. And B would be option A, but allow user agent to actually send like from time to time the same events so that the web application might react to it or not. Thoughts?
That sounds reasonable to me. Some kind of throttling mechanism.
Yeah.
I guess it doesn't matter exactly which one.
Well, we would define the algorithm, in the stack so that all user agents would do the same. Yeah.
Once per second or who knows? I don't know.
Yeah. Oh, yeah. Maybe we would not precise it in terms of the timing, but at least whether the events are the same or not, basically.
Right.
Harald?
Throttling is good. It's good, and having a simple algorithm for the throttling is also good. Having throttled a lot of messages in the past, and so a simple algorithm like if the error is the same, error code is the same as the previous error that might have been thrown, then throw it away. I think that's simple enough. I mean, if you get unknown key 7 times in a row, that tells you nothing. But if you get unknown key and then a bad 8-frame format, then the next unknown key might be something different.
Yeah,
keep it simple.
Yeah, the only caveat is unknown key with same key ID. Like, you might want to say, hey, there's a new key ID. So that's the only caveat. But yeah, that would be simple like that. Okay, I don't know if I can get another minute or if it's too late and we.
Well, could we skip to the next section and then if I finish early, we can go back?
Yeah, sounds good. Sounds good to me. Thank you.
I'll try to be fast. This is the grab bag. We have 3 issues. So let's talk about JavaScript. Well, okay. We're jumping into the first one. This is issue 3104. Consider averting nullable max message size. So JavaScript quiz, if you type JSON stringify max message size infinity, what do you get? I think someone flashed the answer there. So next message, you get null, of course. So next slide. So basically in March, we added early exposure of the pc.sctp attribute. It's like now exposed and have a local and remote offer. And it made, the PR made SCTP max message size nullable, mistaking it for Chrome and Safari behavior. What happened was I learned not to use JSON stringify for fancy logging of objects because the correct behavior is that Chrome and Safari, even though they specify a number like 262,000 bytes in the offer, both Chrome and Safari expose infinity in the SCTP max message size before you get the negotiated value. Firefox, on the other hand, also has a finite number, a larger number in the offer, but exposes 65,536 as the initial value. And these values change once negotiation goes back to stable, then you get the actual values. But there's no null anywhere, so basically the proposal is to revert nullable max message size. And so you can decide that on this slide, or you can get more information on the next slide. So maybe the next slides, and we can come back to this one. So what does that spec say then? So the spec initializes max message size by basically calling the updated max datagram message size algorithm. Harald?
Just to the point that isn't on the slide, updated data message size algorithm is only referenced by the processing of answers.
No, it's also initialized.
Yes, it's initialized to null.
Right now it was, but before this PR, it was initialized by calling this very algorithm. So if we remove the nullable, then it can't be null. And the old language,
it was initialized by calling this algorithm when creating the object which happened at answer time, if I remember correctly.
The algorithm may have been only written with answer in mind, but if you go back to the spec in February, it did say that when you create the interface, you call this update mechanism. However, since that object was only initialized in the answer, it's true that calling it this early, this is the earliest it's ever been called, and that's new. Yeah. But what it does say basically is that it doesn't take the local offer into account at all, but that's basically encapsulated in the can send size, which is sort of, can send size is basically the same thing. It's just going directly to the user agent rather than the offer that produced. So basically, TLDR, what it's basically saying is if the remote max message size is missing, then let it be 65,536. And that matches Firefox behavior. So I'm not proposing anything. I'm just saying if we revert the nullable part, which I think was a mistake, the spec does seem to say that max message size, the early value should be 65536, which is what it would be in. Yeah, go ahead, Haro.
I think that's a useless and harmful value, and that it's a misreading of the spec. Because it doesn't, it says if the attribute is missing, it does not account for the situation where the remote description is missing. I mean, if the only sensible values are infinity and the local maximum, 65536 is not a sensible value when the remote description is missing.
Okay, so you would favor exposing infinity in this case?
I mean, infinity is just another way of saying I don't know. If you want to propose exposing can send size instead, that's fine with me too, because that's something that actually gives information to the user.
Right.
But 65536, no, that's just wrong.
Right. So I think I agree that the original algorithm may have been designed for answer, but it does seem to, what it seems clear is that the number 0 is a stand-in for infinite, not necessarily for the defaults. I think that's where the confusion lies here, is that 0 is a special value that means infinite here, and then the algorithm somehow picks 65536 if the remote description attribute is missing, and I don't know what that communicates, but that seems to be some kind of default.
I think it's actually a default from the SDP spec for SDP.
Okay, so why is that not a good value to expose?
Because it's the wrong number. In the case where Chrome talks to Firefox, and Firefox can handle any size, then the result would be that if the application tries to query this number before stable, it will be told that it can send something that is much smaller than will ever be agreed to.
Okay. So, but why? I guess what if we haven't negotiated yet? Is it that different from negotiating with a peer that doesn't specify a size?
Well, it's not the number. It's not a number you want. You're going to end up with. I mean, infinity is a fine number because it's because it tells you that that we don't know yet. 0 might be a good number because we can't promise you that we can handle any size. The other guy might reply 1, and then 65536 is just something that sounds plausible enough to be harmful.
Okay, so the three options I hear. Sorry, Johan, go ahead.
Yeah, I tend to agree. When I see the smaller of something and some other thing, and you don't know one other thing, then you should drop it and just expose either consent size or positive infinity.
Okay.
These are like two, yeah, either one of them.
So I'm hearing 4 options, I guess. One is null. The second is infinity. The third is the number in the offer, local offer. And the fourth is 65536.
Yeah.
Tim?
So given that I tend to not have a number here, I'd rather have something that indicates that it's not a number, because there's no sensible action you can take at this point, like in terms of like building a buffer or deciding an algorithm, because you don't know the number. So I think it's important to signal that this number is unknown as yet. And the only strength of can send is that it is probably the maximum. Like it's only going to get, if the other side is always going to negotiate it down rather than up. So I suppose can send is my second best, but I'd go for null or can send. I don't think any of the made up values are useful contributions in terms of what the developer will do with them. Like if I'm given 655, what do I do with it? It doesn't. I don't allocate a buffer that size because it's wrong, or if I do, it's wrong.
I mean, no user agent is exposing it now, so I would tend to not try to do it just in case. And so I would pick infinity or valid number, consent size, for instance.
Just to shorten discussion, I think we're okay with infinity because that is the current behavior in Chrome and Safari. So that seems to, aligning with that, most implementations seems to be a good thing. And infinity is also, no one's going to allocate an infinite buffer, I guess.
All right.
Hopefully.
All right, is that good? Okay. Next slide. Okay, obfuscation of ICE candidate. We have address candidate and related address is underspecified. So the candidate attribute reading from spec says, if the RTC ICE candidate represents an end of candidates indication or a peer reflexive remote candidate, then candidate, which is the member, is an empty string. So that breaks the question, well, there's a constructor for RTC ICE candidate, so you can make any ICE candidate interface you want. So if you create one that is a peer reflexive candidate, should the candidate member be an empty string? Which kind of seems silly. Ewan?
Yeah, I don't think it's a peer reflexive remote candidate. It's just a peer reflexive candidate that happens to be created.
Right.
So I wouldn't go with empty string there.
Good. All right. How to tackle this?
I don't know what we are doing. I don't know what user agents are doing here. But yeah.
Okay. So there's a question. There's an underlying question here which comes up in the second slides as well. Maybe we can just go through them all. Next slide.
So Yanivar, before going there, do you know what user agents are doing?
I need to do more testing. I think the problem here is really that these are actions at a distance. And I think the defensible behaviors here is if you get selected, if you do pc.sftp.icetransport.get selected candidate pair .remote. In that case, you get so one of the benefits of these interfaces is there can be attributes. If you get that, if you look at that attribute, in that case, the address will be empty string. So there's obfuscation going on. The problem is that the way it's specified is a little odd because it doesn't capture the corner cases of people creating their own interfaces. And there's a lot of wishy-washy language in the spec about, well, if a candidate belongs to this peer connection, these are relationships that aren't really described in algorithms. So if you make a copy of that candidate, it's not clear whether they all, and here, for instance, it says, once the peer connection instance learns of an address by the web application using address candidate, the use agent can expose the address attribute value in any IS candidate of the peer connection instance representing a remote candidate with that newly learned address. So this is action at a distance by design. And it kind of breaks apart a little bit. Are we supposed to... So Firefox is trying to implement this, and we want to know if we're supposed to have this magic member attribute of all these interfaces and keep track of all of them and update them. Does that explanation make sense?
Yeah. So when you're creating an RTCIS candidate for the constructor, you're not attached to anything. So I do not see why there should be any obfuscation.
Right. So I think one proposal here would be to change these to be properties of the construction of the IS candidate, so that after it has been created, you wouldn't update it again. And then you could then perhaps the use agent could instead replace in the get candidate pair example, it could then update the attribute to a new fresh IS candidate that has the address exposed. That would be the contained way of doing it, I think. So you still get the benefit of when you do the get candidate selected candidate pair, you call get candidate selected candidate pair later, and you will see that it might have updated.
So what you're proposing is to add more algorithms that describe how this obfuscation is working.
Yes, and basically, yeah,
seems good to me.
And not have it be magically happening in any IS candidate interface. Does that make sense?
Yep. Yeah, that's better.
Okay. Thank you. I think any other thoughts on this?
So can you give me a brief summary? I'm making a couple of notes to send to Tom. What did we conclude from this one?
Add clear algorithms about when attribute values should be exposed on attributes that happen to be RTCIS candidates. And no magic values in newly created IS candidates from JavaScript. Thank you, Tim, for taking notes. We have one more slide. This is about related address, where it says for a candidate that is derived from another, such as a relay or reflexive candidate, the related address is the IP address of the candidate that it is derived from, which is a little vague, but the main question we had was, well, if the main address is an empty string for privacy reasons, we probably shouldn't expose the related address and related port as well. Is that a rational statement?
Yep.
Okay, that was quick. Not hearing any objection to that. So that was my last slide. Yes. So UN, if you want to do some more S-frame, we can try to squeeze it in.
Okay, why not? Next. Yep. So talking again about the receiver transform, so it has a key store. So basically the web application is adding keys and adding keys and adding keys. And maybe at some point it might want to remove keys. And so there's a remove key method. But the question is, when do you know it is safe? It's actually safe to remove the key from a receiver transform. And it's not very easy currently, because you don't know which key is in use. And even if even if you know that a key is in use at the right time, it does not mean that the previous key will not be used or will not be useful in case it's a late packet or the packet retransmission and so on. So I don't know what we should do there, whether the user agent should expose like a crypto key ID key in use, and or whether it would be misleading. So so the user agent, I guess, should be able to say, hey, I'm able to know when late packets will be dropped, and could delay the change of the key in use to that time, for instance. But it's a bit complex. Or whether it's up to the web application to actually identify when a key is changed and when it could remove the keys. The keys are small, so it's not a big deal to not remove keys, but still it would be good to be able to do some cleanup properly. And if a user agent is not exposing something that is meaningful, then it's a bit hard. What's on that issue?
So I went to a talk about MLS, and their view how to handle big forking groups, and their view was that it was important to keep quite a back history of keys so that you can cope with coalescing, a group coalescing. That, I mean, this is a, so I'm not giving you a number, I'm not even speaking authoritatively, but I would say I think it's good to keep more rather than just throwing them away as soon as you possibly think you might be able to, for that reason. But whether that applies here, I'm not even totally clear, because I don't think you can coalesce a group yet, which you might do in the future.
Yeah, usually as I was always thinking that key IDs would increase. But in the case of coalescing, yeah, you could go back to a previous key ID. That's interesting. Yep, Yanivar?
Sorry, I'm wondering if we could offload this to the application, because I worry that this exposes implementation-defined behavior. Could we instead keep the keys around until the application removes them?
Sure, but how is the web application handling the removal of the key? How does it know that there's not a packet in the future that is coming where the key will be used? If it
Not
might
the
not
user
even
agent's problem.
Yeah.
I don't know.
Okay. It might not even know which key is in use, actually. So it might provide like 10 keys and it's not exposed anywhere.
So the user agent knows more in this case.
Yeah. Maybe it's a stat. I mean, I feel like you have a key store and the web application provided the keys, and maybe it should know which key is in use or which keys are in use in the last couple of seconds or whatever. I don't know.
So the time spent between the time to wait until you're sure there's no more packets that might arrive is actually highly application dependent. So if you're a real-time application and you know that you're throwing away anything that comes in more than 1 second late anyway, so then you can safely delete any key that where you've been using a different key for more than 1 second, if you know that the sender is only using one key at a time.
So I would say that you can probably throw away any key that was used that hasn't been used since the new keyframe turned up. So if you've had a full frame, then you'll never need to decode for video. You'll never need to decode something prior to it, even if it does turn up.
Yep, but as a web application, you don't have that information.
No, that would have to be the user agent.
I believe the user agent has information that could be useful for a web application to remove the keys. So, but the question is, as Janivar pointed out, you could define heuristics, but are heuristics good enough, or should there be an algorithm that is like somehow deterministic? And I don't think we can have that kind of algorithm there because things might change. So so yeah, I guess it's a case where we could also just wait for web developers to advocate for that method, because it's not simple, and it can be easily added when there's a need. So once we have like a good usage of the receiver transform.
Experience
What's the
will show.
cost? Yeah, I think so.
Okay.
What's the cost of not deleting them?
Yep.
Yeah.
I'm out
Okay,
of time.
yeah, we're out of time.
Yeah.
Thanks everyone.
Okay,
See you
bye-bye.
next month. Bye.